Alrighty, so I promised you I would show you, give you a screencast of an expected value problem. This can be found on page 198. Expected value is often used, as stated earlier, in lottery, in insurance, which is kind of like a lottery. Let's take a look at this problem. In Virginia's Pick 3 lottery game, you can pay $1 to select a 3-digit number from 000 through 999. If you select the same sequence of 3 digits that are drawn, you win and collect $500. Now, question A here, how many different selections are possible? Essentially, what this is asking is, how many different 3-digit numbers are there from 000 through 999 inclusive? Well, it's going to be 1,000. There are 1,000 numbers from 0 to 999. All right, so this answer to part A is 1,000. Now, what is the probability of winning? Here, the question is asking us, essentially, that same calculation we did earlier when we were talking about the probability of getting 1 heads versus 2 heads versus 0 heads. It's the number of winning numbers divided by the total number of selections. Okay, and so the number of winning numbers, there's only one winning number. But out of how many selections? Out of 1,000 possible numbers. Now the next problem here asks, what's your net profit if you win? Well, remember, net profit is revenue minus cost. Well, your revenue is your winnings, $500. Your cost was $1 to play, so your net profit is $499. Now, part D is the interesting question. Find the expected value. All right, so in part D, the expected value, this is the notation we use for expected value, which is also known as the mean of a probability distribution, which we know is going to be the sum of each value of the random variable times its associated probability. Okay, well, these A, B, and C actually feed into this problem. Well, what value can our profit take on? All right, so the expected value, we're actually looking at the profit. Well, we could earn $499, right? That is one value of X. $499, but the probability associated with those $499 is 1 over 1,000. We have a 1 in 1,000 chance of making $499. And what is the other possible outcome that could happen? Well, our random variable, our profit, could be $499, or it could be -1, meaning we paid $1 and we didn't win. That's -1. So if I'm going to add this to -1, a profit of -1 times its associated probability, well, what's the probability that I pay $1 and I don't win anything? It's going to be 999 out of 1,000. All those other numbers are losing numbers. There's one winning number here, 1 out of 1,000. All the rest of them are losing numbers. And so if you put that in your calculator, what we're going to get is -0.50, which is -50 cents. In other words, you expect to lose 50 cents on this game. Now, obviously, you know that's not going to happen, right? You don't just lose 50 cents, you lose a whole dollar. But over a repeated number of trials, you keep playing and playing and playing, you will lose 50 cents. But if you win that one, when this all averages out, you're not going to lose a bajillion dollars. If you win that one time, this will all average out to you losing only 50 cents. All right? Now, part E says if you bet $1 in Virginia's Pick 4 game, the expected value is -50 cents. Which bet is better in the sense of producing a higher expected value? A $1 bet in the Virginia Pick 3 game or a $1 bet in the Virginia Pick 4 game? I don't know why they asked this question, because clearly both have have expected values of negative 50 cents, so neither is better and neither is worse. And that's an example of how we do an expected value calculation. I hope you enjoy. Bye.